This game has been absolutely blowing up the internet during the last couple of weeks. Every big YouTuber has played it, and this has made the developers literal tens of millions of dollars. And here's the thing, I also want tens of millions of dollars. So today we're going to be recreating Meccha Chameleon inside of the Godot game engine. How hard can it be? It's just a bit of painting, right? But spoiler alert, I was very wrong. Let's first start with the character. This part was actually really easy because this is literally just a white blob. I just extruded a few boxes and added some subdivision to make it smooth, and I called it a day. But one really important thing to get right here is the UV unwrapping. You see, the UV of a model basically tells the game engine how to map an image onto the 3D mesh. My goal is to use as much space on the texture as possible, so that when we need to send this around over the internet to make this a multiplayer game, there's not that much unused space. To control this, I created seams all over the model to tell Blender where to cut up the player's skin. Okay, that sounded very wrong, let's just move on. Next, I want to focus on the most important part, the painting. This part is actually not that easy. As I just explained, the color on the model comes from a 2D texture. So to change it, we need to change the texture. But the player is going to be drawing in 3D, so we need to find a way to convert the player's brush back to 2D to paint on it. I hope that makes sense so far. I started by doing some research, figuring that people would have done stuff like this before, but I was wrong. The only advice I could find was to use physics raycasts. But there's a big problem with that. Using physics would require that we have both a mesh for rendering, but also a collision shape for casting the rays. Although this approach might work well with static models like electrical boxes, houses, or cones, it's not going to work for our player. The problem is that he will be animated. While this works fine for the mesh, the collision shape sadly cannot be animated. I felt like this was the end of the road. I didn't know how I could code something that worked similar to the original game, and no one online could help me. I almost gave up on the project, but I knew that it must be possible somehow. After all, the developers of Meccha Chameleon also found a way. So while thinking of the tens of millions of dollars, I got back to work. I drank a bunch of coffee and activated as many brain cells as I could. And wow, I actually got it to work. I honestly forgot how I came up with the solution, but let me try and explain how it works. The brush is basically its own camera. This special camera is set to only render the character that is being painted and nothing else. The character is using a special shader I made myself that checks whether the normal camera or the special brush camera is currently active. If the normal one is active, it just displays its texture like normal. However, if the character detects that it's being rendered by the brush, instead of showing its normal colors, it outputs the UV coordinates as its color. This makes it look weird, but that's okay, the player will never actually see this. In the next step, I can then use these UV coordinates to know where I have to paint on the texture. So I have to go over every pixel that the brush camera sees and paint the corresponding pixel on the texture. But there's one problem with that. Say the brush is rendering with a resolution of 512 by 512 pixels. That's over 200,000 points I need to fill on the texture. Doing this every frame would, well... But luckily for us game developers, computers have something that is really good at doing many things at the same time. Let me introduce you to the GPU, or graphics card. Since all of these 200,000 operations can happen in parallel and don't depend on each other, the GPU is perfect for something like this. To harness the incredible powers of the graphics card outside of the usual rendering that it's made for, we need to write a compute shader. This is a specialized program that has to be written in a special programming language called GLSL, specifically designed to be executed on the GPU. This is also really convenient for us, because the GPU is also the one rendering out the brush's camera in the first place. So this texture data never has to be sent over to the CPU and can just stay where it is. This will increase performance by a lot. There's only one small problem with this. Compute shaders need to be written in GLSL. I did have a university course on this a year ago, but I sadly forgot almost everything. Writing programs for the GPU is also not fun. A lot of times stuff just doesn't work and you don't even get an error. You can't really debug anything because the graphics card doesn't even have a print function or anything like GDScript does. But thinking of the big mountain of cache, I kept going. And boom, it's working like a dream. Right now it's painting in a square, which is not what we want.
I think that goes in
the circle.
The square hole.
The simple solution I came up with is to just check the distance to the center in the compute shader and skip painting if we're too far away from it. So we only paint in a circle, and boom, circle. I just quickly made the brush follow the mouse, and after one small fix for the perspective, I got that working as well. Okay, let's just slap a character controller onto our white blob so we can move around. Perfect. Now we can move around and hide ourselves into the environment, but it's kinda useless without anyone actually hunting us. So let's make this multiplayer. Joining each other and syncing the player movement is classic multiplayer, so I'm not gonna bore you with that. The difficult part is networking the actual painting. You see, the painting happens about 60 times per second. The texture we're painting on is 1024 pixels squared. We need 4 bytes per pixel, so this would amount to 250 megabytes per second. So unless all of my players have NASA level internet connection, I don't think this is gonna work. Doing some research suggested that I should only send paint operations, so basically the players would be telling each other, hey, I just painted this color from this position. But this has a similar problem as before. You see, because our players are going to be animated and moving around, due to networking lag, the character might look slightly different on your computer than he looks on mine. And if both games paint on the same spot, it might actually end up on different spots. Even though this might not be that big of a problem once, the errors will accumulate over time and the texture will end up looking completely different on one machine compared to the other. I could fix this by periodically sending the full texture to make sure everyone's on the same page, but that seems like a lot of annoying coding work. But luckily for me, Google came to save the day, but not in the way you might think. You see, back in 2010, Google looked at image formats like PNG and JPEG and decided they weren't good enough. So they made their own format. Enter WebP. WebP is a bit similar to how JPEG works, but it's really good at compressing and preserving detail at the same time. It's a bit CPU heavy for encoding and decoding, but that should be fine. Another optimization we can make is not sending the texture on every frame. For a game like this, once per second is more than enough. This brought our networking bandwidth from 250 megabytes per second all the way down to 6 kilobytes per second. A 99.998% improvement. Okay, I needed a small break from difficult things, so I decided to work on adding a color picker, because painting only red might be useful in some situations, but I think that would become quite boring pretty quick. Luckily this was really easy. I must say I really love the Godot engine, it makes a lot of stuff like this really easy to do. Hey, real quick, I just wanted to let you know that these videos take a lot of my free time to make, and if you'd like to support what I'm doing, subscribing is the easiest way to do that. It really helps a lot. Thank you. And back to the video. Alright, enough break from difficult things. Let's add color picking, so the player can copy the exact shade of his background. I expected this to be fairly easy because Godot's color wheel has a built-in color picker, but a problem quickly arose. Let's have a look at this red cube. The actual color is supposed to be pure red, but there's things that make 3D graphics actually look realistic and not just like a children's drawing. Ambient light, direct light, shadows, reflections, PBR rendering, and tone mapping, to name a few. The color that ends up on the screen can be very different from the actual color on the object. So depending on which side of the cube we pick, we end up with a different shade of red. My first idea to solve this was to exploit the fact that Godot renders everything in 4 steps. So I thought if I hook into it early enough, I might be able to extract the color before all of these effects get applied. But unfortunately for me, Godot renders this object together with the shading in one single step, so that's not gonna work. To solve this, I tried doing something similar to the way the brush worked. Having a second camera that renders exactly the same as the main one, except tell that camera to ignore all the lighting, shading and other effects we talked about earlier. I can even render this at a lower resolution to save performance. However, there's still one small performance optimization I want to make for this. You see, the rendered buffer lives and usually never leaves the GPU. To pick a color from this the naive way, we would load the entire texture onto the CPU just to sample a single pixel from it, and all of the other thousands of pixels are being transferred for no reason. So instead of doing that, I quickly used my new gained knowledge and wrote another compute shader that runs on the GPU. This samples one pixel we need and then sends only that color back to the CPU. Nice, another 99.9999, I don't even know how many nines, performance optimization. Most of the mechanics from the original game are finally working, but there's one very important thing missing. Can you spot it? You might have to look a bit closer. There's actually no map yet, it's just an infinite void with a few cubes. I'm quite lazy, so I didn't feel like designing, modeling and texturing an entire map just for this experiment. So I went on itch to see if there's any good free maps I can just download. There's this one artist called Elboliloduro? Yeah, I don't know. That makes amazing things for free. I looked for a map that would work and found this cool burger joint. One import later and the map is in the engine. I just added some collisions and tweaked the lighting a bit and boom. We can now walk around in our new map. Thanks Elboliloduro. Alright, this is sadly all I had time for this week. I'm considering if I should keep going and add my own ideas to this project. Let me know if you'd like to see more of this in the comments. If you enjoyed the video, I'd appreciate a like, and I'll catch you in the next one. Bye bye.